Hi there, this is a video for Algebra 1, and today we're going to actually be covering two sections, 5.1 and 5.2, and we are solving inequalities by adding, subtracting, multiplying, and dividing. And so one of the things that I wanted to say before we even get started is that we are going to solve inequalities in much the same way that we solved equations. So that part of the lesson will be very similar to you or familiar to you. But one thing I do want to point out is that the difference between inequalities and equations is the number of solutions that you get. For example, when you solve an equation, first of all, the symbol is not going to be a greater than or equal to. It's just going to say something like x minus 12 equals 8. And to solve this equation, you would add 12, and then you would get 20. Your answer would be x equals 20. So what happens when you have an equation is that you have a finite number of solutions. In other words, finite means that it's countable. You can count how many solutions are going to make the statement true. The number 20 is the only number that you can plug in for x that will make this equal 8. That, by contrast, when you solve an inequality, you're still going to do many of the same things that you would have done in the equation case. You're still going to add 12 to both sides. That part is the same. And you're still going to get 20. The symbol is going to be greater than or equal to. And now this is very different from it equaling 20, because 20 is only one number. There's only one number that will equal 20. But when I ask you how many numbers are greater than 20, while 21 is bigger than 20, 22, 23, 39, 105, 107.3, there are an infinite amount of numbers that are bigger than 20. So all of a sudden the number of solutions that you have has just grown exponentially or grown dramatically. So I just wanted to be sure that you were aware of that case. But other than that, that's pretty much how you solve this problem. Just check your solution. If I put 20 back into the original problem, I get 20 minus 12 is either greater than or equal to 8. And it just so happens that 20 minus 12 is 8. So in this case, 8 is equal to 8, so that's true. And it works. So now I want you to try this do-it-yourself number 1. Make sure that you check your solution afterward. Then I want to come and talk to you a little bit about set builder notation. And this is the answer we got for the previous problem, x is greater than or equal to 20. And I want to show you how you can write that in what they call set builder notation. So this looks kind of funky, but you've got these little curly brackets here. And we always use brackets when we have a set. And there's 3 parts to our set. We have the variable part. So you have your first bracket, and then you always put the variable in question here. And then this vertical line that's here, it literally means such that. So when you see that, you're going to say such that. And then over here on the other side of that bar is the condition that needs to be met. So basically when I read the set builder notation, I am saying that the answer or the set is all x values, so that's the variable, all x values such that the x value is bigger than or equal to 20. And that's how you would read that. So when we do example 2, we're going to want to write our answer in set builder notation. But in this case, we're going to be using subtraction to solve. So we're going to subtract 19 from both sides. And 56 minus 19 is 47. And I'm going to confirm that. 37, sorry. Okay, but also we want to put this answer in set builder notation. So we're going to say that the answer is the set of all m values such that m is greater than 37, and that would be our answer. So now I want you to try do it yourself number 2, but remember that when you do that, I want you to put your answer in set builder notation, please. All right. Okay. And then we have example 3. And in example 3, the only difference is now that we have variables on both sides of the equal sign. So we want to make sure that we know how to handle that. So you can do this a couple of ways. You can move the 4A's over here or move these 3A's over there. And to me, I'm looking at this problem. If I move the 4A to this side and then move the 6 to that, that's 2 steps. But if I move instead the 3A, I only have to do it in 1 step. 6 is less than or equal to 4A. And then I would divide by 4. And A is greater than or equal to 3/2. Okay? Now, this is saying, this is kind of reading this backwards. We usually put the variable first. So 3/2 less than A is the same thing as A bigger than 3/2. Because again, it's saying 3/2 is smaller than A. So if I want to reverse that, I'm going to say A is bigger than 3/2. Basically, the open part of the symbol is facing the A in both scenarios. So I didn't change what I'm saying, I just rewrote it in a different way. It's the same thing as saying, I am older than you versus you are younger than me. It's a different word, but it pretty much means the same thing. So now I have my value A is greater than 3/2. And in this case, they want us to graph the solution set on a number line. So what you want to do is make a horizontal line like this with little arrows. And of course, put the variable. Always put the variable, so I'm going to put A because that's my variable in this case. And then you always want to put your 0 somewhere. And then 3/2 is 1.5, so if this is 1 and that's 2, 1.5 is in the middle, that's 3/2 right there. And it is equal to, and when you have an equal to, use a solid dot. If it had been a greater than, you would just use an open dot. And then we shade greater than 3/2. Some people like to draw arrows like this. Either is fine. Okay, so now that we've done that, you can try to do yourself number 3. And then we're going to move on to example 4. And example 4 says, Felipe needs for the temperature of his leopard gecko's basking spot to be at least 82 degrees Fahrenheit. Okay, so if it's at least 82 degrees Fahrenheit, it could be 82 degrees Fahrenheit or more. Currently, the basking spot is 62.5 degrees Fahrenheit. How much warmer does the basking spot need to be? So we need to first and foremost write ourselves an inequality. Currently, I don't know why I keep saying basking, I don't know how to say it, but currently the spot is 62.5 degrees Fahrenheit. And it needs to be at least 82 degrees Fahrenheit. So how much warmer? So we're going to go plus some T. We got to add more temperature to that. And then hopefully we're going to get that temperature to be at least, which means greater than or equal to 82 degrees Fahrenheit. That sometimes confuses people, but just think about that. If I said I was going to pay you at least $82, you don't want me to pay you 80. At least means that it's greater than or equal to 82. So even though the word least kind of implies less, at least is actually saying that they're not going to pay you any less than that. So they're going to pay you more. So it needs to be a greater than symbol, greater than or equal to. And so there's our inequality. 62.5 plus T is greater than 82. And then we're going to subtract 62.5 from both sides. And our temperature that we need to add, how much warmer does it need to be? We need to add 82. So 144. I'm sorry, I don't know why I added those. That's wrong. 82 minus 62.5 and put 19.5. All right. So as long as our temperature increases by 19.5, then we will be warm enough for our gecko. All right, so now you can try this word problem. And then that pretty much takes care of 5.1, which is adding and subtracting, where I was telling you that it was way too easy to do only one lesson for this section. So we're going to go ahead and put two sections together. And this is where section 2 starts, 5.2, is basically multiplication division. So I want to remind you that we have a property for inequalities when it comes to multiplication division. And I've highlighted the most important part here. But basically, when you multiply or divide both sides of a true inequality by a negative number, then the direction of the inequality sign is reversed to make the resulting inequality also true. In other words, whenever you multiply or divide by a negative number, you have to flip or reverse the inequality sign. Okay, so, and we'll see that in the next example. But here in example 5, it says, of the students surveyed at Madison High School, fewer than 84 said they have never purchased an item online. Fewer means less than. So we want to translate this. So fewer than 84, so less than 84, said they have never purchased an item online. Now 84, this number represents about 1/8 of those surveyed. So if we say that the number of people that took the survey are going to be X, then it's going to be 1/8 of X. Now remember, X represents how many students were surveyed. Alrighty, so to solve this problem, because you have division by 8 or multiplying by 1/8, you have to solve it by multiplication or division, depending on how you want to look at that. Okay, so I am going to multiply both sides by 8 because I know that 8 times 1/8 will cancel, and that'll give me an X. But notice that I'm not multiplying by a negative number, so I'm not reversing any symbols right now. But 84 times 8 is 672. Okay? So the number of people surveyed was at least 672. Okay? Or sorry, not at least, less than 672 people were actually surveyed. Now, if 672 people were surveyed, then that would be exactly 84, and then it would be exactly 1/8. But like I said, it says that it's fewer than 84, so that's why we're going to get less than 672. So there's your answer for that problem. So now you can try this one on your own, and then we're going to go to this little guy, and now you can see how this has a negative in it. And they want us to graph the solution on a number line. So again, in order to graph this or solve this problem, we want to multiply, because you have -3/7 times r. You want to multiply by the reciprocal of this. So I'm going to put negative so that I can make it positive, and 7/3. Because 7 and 7 will cancel, and the 3 and the 3 will cancel. Negative times negative is positive. So you'll just get r. But whenever I multiply by a negative, I have to reverse my symbol. So instead of this being a less than, it's now going to change to a greater than. And now I have 21 times -7/3. And then I'm going to put that in the calculator. So I get -49. R is greater than -49. And then to put that on a number line, remember we put a horizontal line. We want to label our axis with the variables. That's going to be R. And then negative, so over here we're going to have 0. And then -49 is down here somewhere. Okay, now I don't care if you actually have, 48 tick marks in between, but I need to make sure that you have a 0, that you have the variable, and that you have the number in question here. This is a greater than, so this is not equal to, so we're going to put an open dot, but it is greater than, so we're going to shade to the right. Or like I said before, you can do the arrow thing. Okay? And that is how you do example 6. So it's pretty much the same thing as solving an equation, but again, you have to be really careful to remember to switch the symbol whenever you multiply or divide by a negative number. So keep that in mind as you do these 4 examples. And then we have our last example. Yes, this is our last example. And we're doing the same thing, solving to inequality, graph the solution on a number line. So here, because it's 60 times t, I'm going to divide by 60. on both sides. They're going to cancel, but notice that I'm not dividing by a negative. So 8 divided by 60, I know that that fraction reduces because both those numbers are both even. So beyond that, I'm pretty sure that 4 goes into 60 15 times, and 4 goes into 8 2 times. So t is greater than 2/15. So you want to put a number line, variable, put a 0 somewhere. 2/15 is roughly 0.13333. So if this is 1, 0.133 is over. It's really close to 0. So I'm going to put a open dot right there, really close to the 0. And then it's greater than, or if you prefer, the arrow. And there you go. In this case, I'm going to divide by a -7. And remember that because I'm dividing by a negative, I have to switch this less than or equal to make it a greater than or equal to. And 147 divided by -7 is -21. Put my variable on my number line. Put the 0 somewhere. The -21 will be on the left. It's going to be a solid dot, and it's greater than or equal to -21. Okay? And that is basically how you solve inequalities using multiplication and division. So once you complete do-it-yourself number 7, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.